friends, today we're going to talk about chemical reaction and chemical equation. Let's start with the chemical reaction and what does it mean. So look here with me. At first I will make a reaction for a magnesium ribbon. This is a magnesium ribbon. I will hold it with a holder like this because I will burn it. As you can see here, I take this magnesium ribbon with the holder and then I burned it. What's happened here? I formed a new substance, which is this white powder. So here I changed the substance of magnesium and oxygen, which is the fire, into a new substance, which is this white powder. Let's see actually what happened here. At first there was an oxygen molecule, which is the fire, so I break the bond between this oxygen molecule, forming oxygen atom. Then this oxygen atom goes to the magnesium ribbon and react with it, forming magnesium oxide. So I broke the bond here and I form a new bond here. So I can write it finally as magnesium, which is Mg, plus oxygen, O2, by heating this triangle, mean heating, give us 2MgO, which is the white powder. So if I asked you the mass of the magnesium ribbon after and before I burn it are equal? No. The mass of the white powder is greater or more than the ribbon before I burn it, because before I burn it was just magnesium, but after I burn it, it becomes magnesium with oxygen. So the mass differ, the mass is more. Now let's define what actually is the chemical reaction. Here, as you can see, is the breaking of bonds between the atom of the reactants. This is the atom of the reactants. I broke the bonds here. Then, forming new bonds between the atoms of the product. I formed new bonds here between Mg and the oxygen. So, breaking of bonds between atoms of the reactant molecules and forming new bonds between the atoms of the product molecules. Now let's go to the second point, which is chemical equation. What does this mean? Look here. In this reaction, I said that I make the reaction between oxygen and magnesium to form magnesium oxide by heating. So why should I say all of this? I can simply write it this way. Mg plus O2 arrow give me 2MgO. This is all. So this is the simple chemical equation that I can use instead of saying all of this sentence. So now I can define the chemical equation as it is a set of symbols and chemical formula. Symbols like plus, like this arrow, like this triangle, all of these are symbols. And chemical formula like Mg for magnesium, oxygen for O2 for oxygen, and MgO for magnesium oxide. And although this chemical equation represents the condition of the chemical reaction. Conditions like I use the heat, so I will make this triangle. If I use the pressure, I will make B. If I use any condition, I can write it in the chemical equation. So the chemical equation is very important because it's simple and at the same time it represents everything to me. Now let me show you another example. Here, instead of say that I will make a reaction between hydrogen molecule and chlorine molecule to form a hydrogen chloride molecule, I can write it easily as H2 plus Cl2 with arrow give me HCl. So it's so easy. Okay, but I have a point here. I want to ask you, please count with me. How many hydrogen atoms entered here in the reaction? 2, right. And how many hydrogen atoms produced from this reaction? Only 1, because there is no number here in the back or in front. So I give the reaction 2 hydrogen atoms and then I get only 1 hydrogen. Can it be true? Can it be right? Of course no, because as we know that the substance or the matter cannot be destroyed or created. So I give you 2 hydrogen atoms, you have to give me 2 hydrogen atoms. Now we will do something called balance. Here I have 2 hydrogen atoms, so in the product I will write in the back 2, so that I have 2 hydrogen atoms in the reaction and in the production. This is called balanced chemical equation. Before I balance this chemical equation, it's not true, it's not what happens really in the life, because I have to give you definite number so that you give me this same definite number. This is now called balanced chemical equation. Therefore, I can define the balanced chemical equation as it is the equation in which the number of the number of atoms entering the reaction equals to the number of atoms resulting from the reaction. Then it is balanced chemical equation. Okay, let's see another example. Here, 2, how many hydrogen atoms here? 2. How many hydrogen atoms in the product? Also 2. Now they are 2 and 2, they are equal. Great. But what about oxygen atom? In the reaction it was 2. In the product it's only 1. Because there is no number here, so it's 1 oxygen atom. So I give you 2 and you back it to me 1? It's impossible. So what should I do now? I cannot write 2 here. No, it's wrong. We cannot do it. But we write it in the back as it is. 2, H2O. Now let's back again. Again, how many hydrogen atoms here? 2. How many hydrogen atoms in the product? Oh, it becomes 4 because I added 2. So 2 times 2 equals 4. Now I have 4 hydrogen atoms. What should I do? I have to back to the list number and multiply it again with 2. Now let's count again. How many hydrogen atoms in the reaction? 4. 2 times 2 equals 4. How many hydrogen atoms in the product? 4 also. 2 times 2. How many oxygen atoms in the reaction? 2. How many oxygen atoms in the product? 2, 2. Now I make the balanced chemical equation. Another example. Here. I want to tell you some. When you want to balance the equation, you have to log from the reaction to the product, from the less to the greater. So I will start from the reaction. I have sodium here. How many sodium? 1. So I go to the reaction. How many sodium? 1, 2. It's okay. Then chloride. How many chlorine here? 2. How many chloride in the product? Only 1. So it's not right. What should I do? I will time it with 2, but in the back, not here. It's wrong. I'll write 2 in the back. So now, how many sodium atom in the reaction? 1. How many sodium atom in the product? Oh, it becomes 2 because I multiply the product with 2. So I have to back again to the reaction and multiply sodium with 2. Now let's count again. In the reaction, 2 sodium. In the product, 2 sodium. In the reaction, 2 chlorine. In the product, 2 chlorine. Now I have a balanced chemical equation. Another and the last example here. H2 plus NO give us H2O plus N2. Now let's count the hydrogen atom. Hydrogen atom in the reaction, how many? 2. In the product, 2 also. So it's okay. This is good. What about the nitrogen? We have how many nitrogen here? 1.
How many nitrogen in the product? 2. Now there is something wrong. So I will back to the list number and multiply it with 2. Now I have 2 nitrogen, it's good. What about oxygen? Oxygen I have here, after I multiply it with 2, I have 2 oxygen. So I will go to the product, I have only 1. So I will multiply it with 2 again. Now let's go back and count all of them again. 2 hydrogen atom in the reaction, but 4 hydrogen atom in the product. 2 times 2 equals 4. So again I will multiply the hydrogen molecule with 2. Now it's a balanced chemical equation. Okay, why? Why did we do all of what we did? Because we have to keep the law of chemical combination. What this? We have to respect the laws of chemical combination, which are 2 laws. Number 1, law of conservation of matter. This law states that the sum of reactant masses equal the sum of product masses. What does it mean? Look here with me. In this reaction, 2 magnesium plus 2 oxygen give me 2 magnesium and oxygen. So here I have to find the reactant masses and then the product masses. I will tell you that the mass of only one atom of magnesium is 24, and for one atom of oxygen is 16. So that you will get the mass of magnesium will equal 2 times 24 because you have 2 atoms of magnesium, and for oxygen 16 will be multiplied with 2 also because we have 2 oxygen atoms. Now the summation of both of them, oxygen and magnesium, all the reactant molecules, will give me 80 grams. Now we find the mass of the reactant molecules, all of them together. What about the product molecule? Look here. I have 2 MgO, so 2 times, between brackets, 24 for magnesium plus 16 for the oxygen. It will give me 80 grams too. Therefore, I have 80 grams for the reactant and 80 grams for the product. Now I conserve the matter, or I respect the law of conservation of matter. You give me 80 grams and I give you 80 grams too. The second law, or I will show you an example here before we see the second law. Here again, hydrogen plus chlorine give me hydrogen chloride. With symbolic equation, H2 plus Cl2 give me 2HCl. Here I told you that the mass of one hydrogen atom equal 1. So you will time it with 2 because you have 2 hydrogen atoms. And I told you that the mass of chloride is 35.5. So again you will multiply it with 2 because you have 2 chlorine atoms. This is for the reaction. So you get the summation 73 grams. What about the product? Here 2 times, between brackets, 1 for hydrogen, 35.5 for chlorine. Again, it will give you 73 grams. Now, the mass of the reactant equal the mass of the product, and therefore, you again respected the law of conservation of matter. Number 2, the law of constant ratios. What is this state? This law states that the chemical compound is formed from combination of its elements by constant weight ratio. By constant weight ratio. What does it mean? Look here with me in this example. It's so clear here. If I told you that if I want to make a reaction between the lead and the sulfur, so that they give me lead sulfide, I have to use 15 grams of lead with 3 grams of sulfur to give me 18 grams of lead sulfide. This is the constant ratios for this reaction.
What does it mean again? It means that if I give you 15 grams of lead and 6 grams of sulfur, what will happen? You told me that 15 grams of lead reacts only with 3 grams of sulfur. So here we will have more 3 grams. What will happen for this more 3 grams? They will remain without any reaction. And the reaction will take place only with 3 grams of sulfur with that 15 grams of lead, forming the 18 grams of lead sulfide. Okay, again, if I gave you 20 grams of lead with 3 grams of sulfur, you told me that 3 grams of sulfur react only with 15 grams of lead. So here we have more 5 grams. What will happen for this 5 grams? They will remain without any reaction, and the reaction will take place only with 3 grams of sulfur and 50 grams of lead to give me 18 grams of lead sulfide. This is called constant ratio or constant masses. I give you mass. I told you this mass react with a definite mass. So if you want to make the reaction, you cannot use more or less than this definite mass. The last point in this lesson is types of chemical reaction. After we know what is the chemical reaction, breaking of bonds and forming of new bonds, after we know that we have to balance this chemical equation of the reaction, now what are the types of these reactions? We will consider only the direct reaction. We add something to something, so we have the product. It's called a direct reaction. And there may be 3 forms or 3 types of direct reaction. Maybe between element and element, like carbon with oxygen. Maybe between element and compound, like oxygen with carbon monoxide. This is compound because it's composed of more than one element, composed of carbon and oxygen, so it's compound. And maybe it's compound plus compound, like hydrogen chloride with ammonia. Let's see each one of them. Element with element, like when I make the reaction between carbon and oxygen, so that I can get carbon dioxide. This is non-metal with non-metal. Or it may be metal with non-metal, like if I make the reaction between magnesium with oxygen to form magnesium oxide. So again, in element with element, I can make the reaction between non-metal and non-metal, or metal with non-metal. This is number 1. Number 2. Element with compound. It's like when we make the reaction between carbon monoxide that acts as a compound and oxygen, which is the element. So by heating, I can get carbon dioxide compound. This is number 2. Number 3 and the last one, compound with compound. Like when we make the reaction between ammonia that acts as a compound and hydrogen chloride acts also as compound, so that I can get ammonium chloride compound. Now we finished the 3 types of reaction, and let me ask you some questions. Here in this reaction, I make the reaction between nitrogen oxide plus oxygen molecule. So can you give me which kind or which type of reaction is this? It is element with element, element with compound, or compound with compound. Perfect. This kind of reaction is element with compound. Element, which is oxygen, and compound, which is nitrogen oxide, because it has nitrogen and oxygen. It's a compound, not element. Number 2. Hydrogen with chloride to give me hydrogen chloride. Which type of reaction is this? Great. Element with element, because here hydrogen only with chlorine only, so it's element with element. Okay, number 3 and the last one Here, as you can see, the reaction is between ammonia, which is NH3, and nitric acid to give me ammonium nitrate. So which kind of reaction is this? Yes, compound with compound, because NH3 is formed from nitrogen and hydrogen, so it's compound. And nitric acid formed from hydrogen, nitrogen, and oxygen, so it's all the compound. Finally, we can say that we have three types of chemical reactions, which is element with element, element with compound, or compound with compound. Thank you so much and see you later.